Just in case you don't know who I am, my name is Maxime. I've been working with Silverstripe since around 2011, and I work at Silverstripe for about 6 years, including 2 years as the CMS squad team lead. So basically, during that time, I was the person who was most directly responsible for managing the project on a day-to-day basis. And this is my fourth time presenting at StripeCon. And today I will talk to you about security in open source. But before that, I will do a shameless plug for my current employer, Archipro. So I left Silverstripe in July and I joined Archipro as a senior software engineer. And at Archipro, our mission is to simplify the end-to-end building experience for homeowners and professionals. So the idea is that if you're a person who needs to build a project of some sort, then you can easily find companies and professionals to help you do it. And we are currently operating in New Zealand and Australia, but have plans to launch to the United States and Europe over the next few years. Our platform is built on Silverstripe CMS. We have many fine roles we are currently advertising. You do have to be in New Zealand and Australia to apply for them, unfortunately. But if you are interested, you can visit archipro.co.nz/careers to learn more. This brings an end to my shameless plug. Now we can go into the presentation proper. So first, a disclaimer, I am not an InfoSec expert. If I was an InfoSec expert, I would be charging you thousands of euros for the privilege of listening to my presentation today. Most of my experience in this field comes from working at Silverstripe, but I don't work there anymore. I'm not speaking on behalf of Silverstripe. I'm just speaking as myself, as an informed and concerned citizen. In my capacity as CMS Squad team lead, I was a subject matter expert on the Silverstripe Information Security Steering Committee. So that meant that about once a year, I would take part in security audits to discuss our security practices in developing Silverstripe CMS. The presentation I will be giving to you today has been specifically refined over several years to put auditors to sleep and make them go away. While today's presentation is mostly focused on how Silverstripe manages product security, a lot of the lessons and approaches that Silverstripe puts in place, you can probably apply to your own products or your own projects. So today I will be talking about all the hard work that the CMS squad and the rest of Silverstripe does behind the scenes to make sure that Silverstripe CMS is a secure platform for all of you to build on. So while the presentation I will be giving today is about Silverstripe CMS, it's not really a technical presentation. So security definitely has technical consideration associated with it, but to really understand how to keep your users safe, you must have like a more wide-ranging understanding of how humans interact with the internet, how they interact with your product, and how they interact with the world more generally. So what you can expect to get out of the presentation today is if you're a Silverstripe CMS developer or if you sell Silverstripe CMS-based solution, well, you'll hopefully walk out with a better understanding of how the Silverstripe security process works and how you can integrate it with your own process. If you look after an open source library or some sort of software product, you'll be able to learn some of the procedures and tools that Silverstripe uses and hopefully apply it to your own use case. And if you're just a general Homo sapien living in the digital age, you'll probably come across the occasional scary headlines about vulnerabilities and exploits. So after my presentation today, you'll be better equipped to understand what those headlines means and take meaningful actions to keep yourself safe. So for those of us who are getting a bit on the older side, we will recall a time maybe in the late 90s or early 2000s. That's the time when the internet really became something that anyone and everyone would be using. And it was an exuberant time, and people were trying to sort of find the boundaries of this new like World Wide Web frontiers and see where the limits were. So for example, in January 2000, Yahoo was worth $125 billion US. So to put that into perspective, that was twice the GDP of New Zealand at the time. So for the price of Yahoo, you could have bought New Zealand 2 times over and you'd still have 11 billion to spare. everyone were really concerned that a bunch of COBOL developers in the 80s like forgot to reserve enough space digits to store dates, and that all the dates would like go away on January 2000. On the security front, people were discovering that maybe not everything on the internet was all peachy dandy. So the I love you virus was being spread like wildfire by email. And a bored teenager managed to bring down the website of Yahoo, eBay, CNN, Amazon, and Dell over a weekend. Software vendors didn't really know how to handle security concerns at the time. So the approach to managing security was look more or less something like this. So first, you should aim to never have any vulnerabilities whatsoever in your products. And in theory, if you follow the few prescriptive rules, like if you install the right antivirus, if you enable the right firewall, if you follow the certain procedure, then you would never be hacked at all, in theory. And you shouldn't talk about how you handle security. You should keep everything secret and keep all your processes close to your chest. And if by some error you manage to find a vulnerability in your software, you definitely shouldn't tell the world about it. You should just try to patch it under the radar without telling anyone. And if someone somewhere managed to find a vulnerability in your software, then that was an horrible disaster, and like you should be ashamed of yourself. And very often companies would turn around and do ads to try to shame their competitors whenever they were suffering a security breach. And you would have ads with like this one by Apple. And I realized that I forgot to share my sound. So you're probably not hearing anything right now. Cool. 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 So hopefully everyone remembers this one. So the old approach might have been the old approach might have made some degree of intuitive sense, but over time, software vendors realized that it had a lot of problems. So a zero vulnerability approach is not a practical or desirable goal. So for example, most tech products are composed of hundreds, if not thousands of dependencies. Any one of those could introduce vulnerabilities in your product. So the threats you face today might not be the ones you face tomorrow. So you can't just rely on prescriptive rules, because those rules might not apply and they might become irrelevant overnight. And those annoying humans have a tendency to ignore your rules anyway, and you can't just upgrade them or like put firewalls in front of them. So eagle-eyed researchers and hackers are also proving themselves quite adept at finding holes in your systems and like reverse engineering your patches and like discovering the vulnerabilities you're trying to keep secret. So while in theory patching like things on the radar might be look like a good idea, in practice it increases the risk of zero-day vulnerabilities, and it actually makes it impossible to have meaningful conversation with your customers and tell them what's going on and like why they should upgrade quickly. And while you shouldn't be proud of having vulnerabilities in your product, being ashamed of them is actually self-defeating. Focusing on assigning blame just makes it impossible to have like meaningful discussions about the problems, learn from them, and implement remedies. The threats that one company might face will usually be faced by many other companies, and competitors are better off collaborating by sharing security practices than competing by shaming each other. So over time, as the tech sector matured, our understanding of how to manage security and vulnerabilities evolved, and so did a lot of the old attitudes. Nowadays, companies that are serious about security will adopt a risk management strategy. So life is complex and unpredictable, and risk management helps you deal with that complexity and that unpredictability. When managing risk, a good first step is usually to try to catalog the risk that might be affecting you. Identifying the so when you're identifying risk, you should have a wide-ranging understanding of what a risk is. So vulnerabilities in your software are an obvious risk, but there are many other types of risks that you have to consider. So you should consider technological risk, but also like human risk, like social engineering. Some risk might involve deliberate attempts by malicious actors to try to access your systems, but they could also be like accidental risk, where like just data gets leaked by accident without anyone actively trying to make it happen. And basically any bad thing that might happen to you could be, in theory, considered a risk. So once you have a good list of risks to manage, then the next thing you want to do is try to evaluate their impacts and their probability. Uh, so in this case, impacts just means that, okay, like how bad is the bad thing going to be if it does happen? And probability means that how likely is the bad thing to happen in the first place? And that will allow you to identify the key risks that you'll need to manage. So you can move on to the next step and decide like how you're actually going to handle those risks. There's four broad strategies you can use to sort of manage your risk. So first, there's acceptance. So not every risk is worth addressing. If a risk is low impact and low probability, then maybe you can choose to just live with it. And if it does happen, then you'll just deal with it then. And on the other end, you'll have risks that are high impact and high probability. And then maybe you just put in play. So yeah, so maybe you just decide that you cannot live with those risks at all, and you just have to put measures in place to make sure that they never happen whatsoever. So that in that scenario, that would be called avoidance. In other cases, maybe the risk is not so likely or so impactful, or maybe avoiding it is maybe there's no practical way of avoiding it. So in those scenarios, you can try to put some mitigations in place. And so normally mitigation will be something that makes the risk less likely to happen without completely eliminating it. Or if it does happen, your mitigation might make it less bad, so it's more manageable. And finally, you can let someone else deal with the problem and just transfer it. So that's normally done through measures like buying insurance. So the strategy you choose to manage your risk will usually take the form of various controls that you'll implement for your system. So for example, maybe you are concerned about malicious users gaining access to your website. So one control you can put in place there is enable multi-factor authentication and make it mandatory for your users to sign up. But unfortunately, even in the best cases, you'll occasionally come in some situation where you will occasionally come across risk that you couldn't foresee. But that doesn't mean that you can't put in place like general plans and strategies to handle those unforeseen risks. So that way, like when the bad thing does happen, even if you didn't expect it to happen, then you can turn around and have a more effective approach to coordinating with your teammates. Most importantly, you need to ask yourself, like, what's your risk tolerance? So you need to balance risk with other constraints like convenience and costs. If you spend all your time making sure that the bad things never happen to your company or your product, then you won't have time to make sure that the good things happen and to seize opportunities as they arise. For example, you could configure a website to require the user to re-authenticate every single time they perform an action, or completely disable JavaScript to avoid like cross-site scripting attacks. But then most of your users wouldn't want to use that website because it would be very painful. Your risk management strategy should be adapted to your specific use case. So let's take a concrete example here. So one of the most commonly requested features in Silverstripe CMS over the years has been the ability to natively upload SVG file. Historically, Silverstripe has always resisted adding support for SVGs because these files can contain JavaScript payloads, which basically is a vector for like cross-site scripting attacks. So the risk here is that a malicious user would somehow find a way to upload a file in the CMS, and then that file would be served in the front end, and that could be used to target legitimate users to basically attack them with XSS attacks. So if we look at that risk from the CMS squad's perspective, so Silverstripe is used by thousands of websites across the world. And if Silverstripe decided to enable like native SVG support tomorrow, it's highly likely that someone somewhere would be able to upload a malicious SVG to a Silverstripe CMS website. And on the impact side, a lot of Silverstripe clients are big businesses or governments that deal with sensitive personal information. So if you manage to put a website, if you manage to put a malicious SVG on a site like that, that could be quite bad because that could lead to data leaks, that could lead to reputational damage to the government or the business or Silverstripe directly. So from Silverstripe's perspective, that's a pretty big risk, and that's definitely something that that has to be considered. In terms of implementing possible controls, like from Silverstripe's perspective, like you could, it's not impossible to mitigate that risk. You could put in place some measures. But because Silverstripe is targeted at like thousands of different websites, and we don't know the situation of all these websites, like developing a solution that could work across the board would be somewhat difficult and expensive. So over the years, the approach Silverstripe has adopted has been to avoid the problem by just disabling SVG's uploads altogether. And you'll find that's generally the approach that Silverstripe takes for a lot of issues on Silverstripe CMS. Basically, Silverstripe CMS aims to be secure by default. But fortunately, most of you are not working in the abstract across like thousands of websites. So you can afford, you have a better understanding of how you're using Silverstripe CMS in your specific use case. So you can adopt a different mitigation strategy, and you shouldn't just like, and you can decide to enable SVGs in some scenarios. So maybe your website is pretty small and you don't manage any sensitive information on it. So you just decide that the convenience of SVGs outweighs the risk of having an XSS attack. And that would be an acceptance strategy. And that's a perfectly fine option depending on your use case. Or maybe you enable SVGs, but you implement a scanning solution so that when the file is uploaded, it's automatically scanned for any cross-site scripting payloads. Or maybe you implement content security policies, so to just block like unexpected JavaScript requests. In that scenario, you're choosing to spend a bit more money to implement a more sophisticated solution. You might not completely eliminate the risk, but like you're certainly mitigating it pretty well. So ultimately, the most important point here is that you have to make a purposeful decision that is suited to your specific need. So if we contrast the 2024 approach with the 2000 approach, so first you have to accept that you will be hacked at some point. Your products will have vulnerabilities, and you should plan accordingly. So there's a wide class of vulnerabilities that could be affecting your software, and you should take steps up front to identify and manage those risks. And you should design your system with the expectation that they will be compromised at some point. So you need to have like a multi-layered security approach where so that way if an attacker manages to break into your system, even if they get some unauthorized access to some components, try to limit the ability to do damage to other components within your website. And the threat you face will change over time. So you can't just adopt like a prescriptive sets of technology and call it a day. So you have to adapt your approach. You have to adapt your approach to the specific risk you face in your use case. And you have to review your situation every couple of years to make sure that you identify new threats as they emerge. And trying to be secret or cagey about defects in your software actually increases your risk in the long run. So being transparent about how you handle vulnerability and more generally, and security more generally, like will allow you to have like more meaningful discussions with your customers and help them better manage their own risks. And it also allows you to have more meaningful conversations with third parties and the security community. And that way you can take lessons from them and make your processes more robust. As an industry, we should also collaborate with our competitors to share best practices and learn from each other. And that way we create a more safe environment for everybody on the internet. So far I've been talking in high-minded abstract terms, but now let's look at how risk management looks in practice for Silverstripe CMS. Specifically, we're going to look at how Silverstripe manages vulnerabilities. So obviously the best way to manage vulnerabilities is to try your best not to ship them in the first place. So there are some controls that the CMS squad has used over the years to avoid introducing vulnerabilities in the CMS. So whenever a substantial change is considered, the CMS squad will usually do a risk analysis to try to identify like what could go wrong with this change. So that doesn't only cover aspects like new features and like major bug fixes, but also like processes. For example, like how our GitHub repos are set up, how to manage third-party dependencies, or how to configure like CI/CD pipelines. So one benefit of front-loading those discussions about security is that it's a great way to remind the team of what they need to look for as they implement the solutions, instead of like just looking at it at the end of the process as an add-on. And obviously there will be peer reviews. So that's a great touch point for the team to just like review the codes, review each individual changes, and just identify security defects before they are actually added to the code base. Silverstripe also documented security best practices, and to make sure that so Silverstripe documented security best practices, and it requires all its developers to review them like once a year, and those security practices are public as well, so you can review them as well. Also, whenever Silverstripe does a minor release or major release of CMS, it contracts a third-party independent auditor to review the code changes and see if there are any security weaknesses that have been introduced. Obviously, that's not a guarantee that new vulnerabilities will not be introduced in the CMS, but it does significantly reduce the risk. But let's say all else fails and you do find a vulnerability in the CMS. So the worst fear of the CMS squad is discovering a vulnerability because it's actively being exploited by malicious actors on the internet. So if you are going to find out about a vulnerability in your system, you would rather learn about it from a friendly user or from a security researcher. So you want to make sure that people who find vulnerabilities have a clear and simple way to confidentially disclose it to your team. So for Silverstripe, the way this is done is just simply emailing security@silverstripe.org. And this is one area where you as a community member can get involved. So if you do come across a bug that looks like it could be exploited as a vulnerability, you can just send an email to that address. Like any good bug report, please provide a clear description and reproduction step and as much details as possible. Most importantly, report even if you're not sure. Vulnerabilities are not always clear-cut. Sometimes you need to have like a discussion about the bug to decide if you want to handle it as a security vulnerability or a security enhancement. There have been a few instances over the years where someone reported a vulnerability in a public GitHub issue, and sometimes they didn't even realize the bug the bug they were reporting was actually a vulnerability. It's only at triage time that somebody realized, well, this could actually be exploited. So once the CMS squad has a vulnerability report, the next step is to review it. So not every vulnerability is some catastrophic disaster that requires some master hacker to be exploited. So basically any condition that allows you to view information you shouldn't be able to see, or alter information that you shouldn't be able to edit, or just otherwise deny other users access to the system is considered a vulnerability. A vulnerability can be as simple as a regular user can view draft content on the live site. When the CMS squad reviews potential vulnerability, they'll usually go through a couple questions. So first one, is it spam? Believe it or not, they are fake security researchers that will try to report dummy vulnerabilities hoping to get a bug bounty. Usually they'll try to make their bug reports as convoluted as possible to try to obfuscate the fact that they are nonsense. And I've literally like wasted hours trying to evaluate some of those. So. The next question is, can it be replicated in a vanilla Silverstripe install? So like any bug, there will always be like these occasional questions where we're not sure if the bug is in Silverstripe directly or in the actual website of the third party that's developing it, or in some sort of in between the two. So there's occasionally a need for a back and forth there. The next question is, can it actually be exploited and in what context? So sometimes the CMS squad will look at a bug and think, well, that's not a great behavior, but we can't really think of a way this could be exploited in practice. So those are usually handled as security enhancement. The unfortunate reality is like taking an issue through a security process has quite a bit of administrative overhead. So like when we come across a bug that doesn't actually have like any exploitable vectors, we'll tend to sort of just treat them as security enhancements, and that can be fixed in public without too much process around it. So for example, a wee while ago, someone pointed out that they could set a blank password for users in the CMS. But because the CMS login form marks the password field as required, you couldn't actually log in the CMS with your passwordless user. So in the end, we decided to tweak the member validation to just disallow blank passwords altogether. And almost immediately, someone complained that they had a legitimate use case for having a blank password. So we had to add an extra feature on the next release to allow people to disable that validation. And once the CMS squad has concluded that yes, a bug is a vulnerability, the next question is how impactful is it? And to evaluate the impact of a vulnerability, Silverstripe uses the Common Vulnerability Scoring System, or CVSS for short. CVSS is an internationally recognized standard for measuring the impact of vulnerabilities. So most vendors will use that approach to communicate the impact of the vulnerabilities affecting their system. So I'll quickly run you through like all the options you see on the screen there. So first we have the attack vector options. So that's basically just documenting like how the attack is propagated. So in Silverstripe CMS case, it's almost network. But let's say you had a vulnerability that required the user to plug a USB stick in your computer. That would be like a physical access. The next bit is attack complexity. So attack complexity is just measuring whether the attacker needs to have any special condition to be able to exploit the vulnerability. So in some contexts, a vulnerability can only be exploited in like specific circumstances that are outside the control of the attacker. So when in those scenarios, then the attack complexity will usually be bumped to I. Then there's the question: do they require any special privileges to exploit the vulnerability? So just for context, like just because a vulnerability requires, say, CMS access to be exploited, that doesn't mean that it's not a vulnerability. So if a content author can see or edit information that they shouldn't be able to see, that's still a vulnerability. So that still needs to be addressed, and that will be patched like a vulnerability that could be exploited by an anonymous user. So in this context, low means a user that has an account on the system, but maybe doesn't have privileged access. While I would be someone like an administrator that has like access to basically all the administrative function in the CMS. User interaction covers the scenario where basically you receive an email with a malicious link, you click on it, and something happens that you didn't intend. So just basically that just covers those scenario where basically those phishing attacks that you can use to try to fool a user to perform an action they didn't intend to do. Scope is a bit of a complicated one. So basically the question here is like, does the vulnerability allow you to compromise some system that exists outside the component that's being edited? So in this case, in the CMS example here would be a remote code execution. So let's say you had a vulnerability that allowed you to run a bash script on the underlying server. Then by compromising the CMS website, you'd be able to compromise the server that's hosting it. So in that scenario, your vulnerability allows you to get outside the system that's being managed here. So fortunately, we don't get many of those in the CMS. And finally, we have impact metrics. So impact metrics just covers like what's the actual impact of the vulnerability when it's exploited. So confidentiality in this case means, can you actually read information that you shouldn't be able to read? So the difference between low and high here is so let's say an attack allows you to impersonate a user, but you're still constrained by the permission of that user. So basically, if that user doesn't have access to be able to see a specific part of the website, you as an attacker won't be able to see it. So that would be considered a low impact. High confidentiality impact would be a vulnerability that allows you to view anything you want, no matter what. So that would be something like an SQL injection vulnerability that just allows you to run raw queries against the database and get any information you want out of there. Integrity impact is more or less the same thing, but for updating or deleting data. So if you have a vulnerability that allows you to delete some data, but not all of it, or you're constrained by some other security consideration, then that would be a low integrity impact. If you can edit any information you want, then that would be a high integrity impact. And finally, availability impact, that just covers your typical denial of service attacks. So that's essentially like, can you stop other users from accessing the website? So if you can stop some users from accessing a component within the website, then that would be a low availability impact. If you can just stop all users from accessing any parts of the website, that would be a high impact. So understanding the system is actually quite useful because it's used by Silverstripe, but it's also used by many other software vendors. So if you understand how the CVSS system works, then you can understand how pretty much all the vulnerabilities for any software you use works. And this calculator is available on the MITRE website. So you can go there, flip some switches, and see what numbers you get. So it's hours of fun for the entire family at home. So once you have a CVSS score, it's important in the CMS context because that will decide in what version of the CMS the vulnerabilities will be patched. So we have 4 broad categories of vulnerabilities. So the low impact ones are ones that have a CVSS score from 0.1 to 3.9. We don't get many of those because basically there's not many like plausible combination of switches in that calculator there in Silverstripe CMS that will give you a low impact vulnerability. That would be something like an XSS vulnerability requiring like full administrative access to exploit. Medium impact, that's the vast majority of the vulnerabilities we get are medium impact. So that's 4.0 to 6.9 on the CVSS scale. So that would be something like a content author can inject an XSS vulnerability on the website, or a content author can view a report that they shouldn't be able to see. Next up, we have the high impact vulnerabilities that have a CVSS score of 7.0 to 8.9. So that would be something like an SQL injection vulnerability that requires a user account, or basically like whenever you have the ability to write raw SQL queries, you can pretty much get any information you want out of the system. And then finally, the highest level is critical. So that's vulnerabilities that have a CVSS score of 9.0 to 10. So that would be something like an SQL injection vulnerability that doesn't require any user account or remote code execution. So those are generally pretty bad. Fortunately, the Silverstripe doesn't get many of those. So once we have an impact, the Silverstripe, the CMS squad will then start working on patching the vulnerability. So the CMS squad tries to develop those fixes in secret. That's one of the rare instances where the CMS squad will work in private. So basically, we cannot work on vulnerabilities in public because if people see us discussing the vulnerabilities in public, then they could use that to start attacking other people that are using CMS. So those vulnerabilities are developed in secret. Like any change, it goes through a peer review process, and during that peer review process, knowing the CMS squad will have a look around and see like, okay, you made a mistake once. That usually means that there's a good chance that you made a similar mistake elsewhere in the system. So like we'll sort of look around, see can we find similar vulnerabilities beyond the exact report we got. And usually the CMS squad will try to learn lessons from the mistake. So sometimes the mistake was made ages ago and the process have completely changed since then, and like there's not really any lessons to learn. Other times you can see the similar vulnerabilities happening over and over again. So that happened once in CMS4. So you may remember that in CMS4, when you were generating a URL to a file, the CMS would automatically grant the current user session access to view that file, even if they didn't have current view right on the files. So we had a string of those vulnerabilities in CMS4. So in CMS5, we decided that this was a systematic problem. So we decided to reverse that behavior. So in CMS5, when you generate a URL to a file, it will, if you want this current session to get access to view that file automatically, then you have to sort of like say it. You have to just say it explicitly in the parameters of the function you use to generate that URL. Okay, now we've developed a fix, and it's time to release and disclose a vulnerability. So it's not practical to support every single version of the CMS indefinitely. So Silverstripe tries to be predictable with the community in terms of like which version will receive patches and when. So we're doing that. The Silverstripe is doing that by having a constant and predefined release schedule. So Silverstripe does 2 minor releases a year in April and October. And those releases are audited. So that means that they go through an independent audit. And that's those 2 points or moments where Silverstripe will disclose vulnerabilities. The other time vulnerabilities might be disclosed is January and June. So those are like in between releases, between minor releases. And those are not audited, but those are not audited during when they are released, but they are really audited as part of the follow-up minor release afterwards. Right here, we have the support timeline for Silverstripe CMS. So there's 2 levels of support. So first, there's the bug and security fix level. So that's normally only the latest version of Silverstripe CMS that gets that level of support. And that basically means that, so for example, right now, if Silverstripe were to patch a low impact vulnerability right now, it would only be patched in CMS 5.2. The level down from that is security fixes only. So that's for older releases. So that basically means that if a vulnerability will only be patched in those releases if they have a CVSS score of 7 or above. So those are high impact or critical vulnerabilities. So right now, the current releases that are in that level of support are the ones in yellow here. So that's 4.13, 5.1, and 5.1. And so when a release reaches end of life, that means that we won't patch vulnerabilities in them no matter what. So that basically means that so those are releases like CMS 3, CMS 4.12, and CMS 5.0. So if you're still on those versions and the vulnerability comes up, then your only option is to upgrade the next to a supported minor release. And a very important part when disclosing a vulnerability is having like good comms to go along with it. So the community can understand what actions they need to take and what's their actual risk. So when Silverstripe writes comm for vulnerabilities that they're disclosing, they'll try their best to describe the impact. And they'll try to describe like what component is affected in what circumstances. What Silverstripe will not do is give you like all the details you need to sort of exploit it out of the box. So basically, we're trying not to give would-be hackers like a key and end solution to start like hacking Silverstripe sites. Essentially, we're just trying to give the community a chance to deploy the patch before a would-be hacker would have a chance to start actively exploiting it. Silverstripe, like most security vendors, also publishes CVEs. So CVEs is an international system for like an international database for reporting vulnerabilities. And it works end in end with the CVSS score. So basically, you can go in the various databases that will just list you like all the vulnerabilities for a specific product, what versions are affected, and what's the impact of those vulnerabilities. And that will also feed into third-party tools like dependency management systems or automated notification. And that way you'll get automated notifications when you're running software that might be affected by vulnerabilities. So one thing to keep in mind is not every security patch will require you to drop everything you're doing and deploy it immediately. So like any release, you'll want if you have to do a security release, you want to do like proper planning. So when the new vulnerability is disclosed in Silverstripe, you should take time to review the score. How critical is it? Is it the low impact vulnerability? Is it a critical vulnerability? What component is affected? So is it maybe you don't even use a component, therefore you don't have to do anything immediately, or maybe you need to do some testing up front to make sure that the security patch is not going to break some of the features on your website. And one thing to note is that when Silverstripe evaluates the impact of a specific vulnerability, it doesn't make assumptions about like what kind of systems you're running. So let's say, for example, it's not going to assume that you're going to have a CDN on your website. Now, I'm going to assume that most of you are running CDNs on your website, and that that has the possibility of mitigating the impact of some vulnerabilities that you might get from running outdated software, for example. So you should probably aim to apply like all the security patches at some point, but most vulnerabilities are not high impact or critical. So it's perfectly fine to ask yourself, like, can this wait until our next regularly scheduled deployment? Basically, you should try to manage your risk associated with that specific vulnerability and make a decision that makes sense for you. So with that in mind, let's see how you can take some of the strategies from Silverstripe and implement them in your day-to-day life. So as a developer, you can adopt risk management in your day-to-day coding practice. So a lot of vulnerabilities get introduced because someone just forgot to do something simple. Like, for example, maybe you forgot to do a can view checks, or you started responding to a request without making sure that the user is authenticated. Or you didn't sanitize an input before using it in a query. So those are all trivial mistakes that you and I and every developer might do every day, but they can have like really big consequences. So by training your mind to always look for them, you can ask yourself, like during peer review, you can go out and say like, okay, I'm looking at a piece of code here, or what is the risk associated with this change? Or like if you're managing a project more widely, you can look, okay, like we're making this change to our system, like what are the things that could go wrong and could introduce like complexity or vulnerabilities in the system. So by adopting that approach, you can make it less likely that the vulnerabilities will be released and you can catch them early. And over time, as you sort of do this over and over again, like your mind starts doing it automatically and you just become second nature. If you maintain an OSS project, you might think, well, that's all great, Maxime, but like I can't possibly have the time to implement this complicated process that Silverstripe has put together. And you're right, you don't have the time to do that process, and you shouldn't, because your risk profile as a volunteer maintainer is going to be very different from Silverstripe's one. So go back to the risk management approach, like review your risk. What's your open source product used for? How is it put together? What are some of the risks that might affect your users? So for a small open source library, those are the kinds of questions that could probably be answered in 15 or 30 minutes. So given the risk you've identified, like are there controls you can put in place to mitigate them for your users? And one thing to note here is that GitHub has a lot of great tools to help with that. So for example, you can set up your GitHub account so that users can confidentially disclose vulnerabilities to you as easily as they report issues. And once you start working on a patch, you can also like create private branches and invite the reporter or other collaborators to help you out develop a fix. And you don't need to be a multi-million-dollar company to start publishing CVs. Like you can do it straight on GitHub. So you can create security notices on your GitHub repos and assign them CVEs and CVSS. And when you publish those security notices, like other users on GitHub will be notified automatically via dependencies alerts. And package management tools will start noticing your vulnerabilities and warning your users as well. And next up, let's say you're an organization that's using Silverstripe CMS to build solutions for other people. So what lessons can you take from my presentations today? Well, I'm going to start sounding like a broken record, but manage your risk. So after this presentation, you should have a pretty good idea of how to report vulnerabilities to Silverstripe, how Silverstripe evaluates their risk and their impact, and how and when Silverstripe will release security patches. So you can build that knowledge into your own processes. So if you know when Silverstripe will disclose a vulnerability, you can build a deployment strategy around it. Or if you know how long your versions will be supported, then you can plan to upgrade before it goes end of life. More widely, you can use risk management when talking to your own clients. So your customers will have different risk profiles. So if a customer just wants a simple brochure site and they don't manage any personal information, maybe it's perfectly fine to not spend time and energy like making sure they're always in the latest supported version. But if your customer is a big bank or a government or deals with lots of confidential information, maybe running software with known vulnerabilities, is even low impact ones, is not acceptable, and that's something that needs to be avoided, and the customer is willing to pay for it. So by having those conversations about risk and risk tolerance, you can make a more purposeful you can have like more purposeful relationship with your customers and provide plus value for them. So finally, I'll conclude with some follow-up steps that you might want to take on your risk management journey. So a couple months ago, my last blog post went up on silverstripe.org, and it was about how Silverstripe CMS approaches secure product development. So it covers a lot of the same topics I've been talking about today. It also has also like some good controls and modules you can add to your website to harden it against potential attacks. So you can go have a look at that on the Silverstripe CMS blog. Another cool thing you can consider doing is attending OWASP meetings. So OWASP is the Open Worldwide Application Security Project. It's a non-profit. It's driven by volunteers, and they have meetups in most big cities and across the world. So that's a great way to sort of join the security community and to talk to people in that space. They also have something called the OWASP Top 10, which is basically the 10 most common class of vulnerabilities for software product. So whenever you do a risk analysis, it's always a great first step to go through that top 10, that OWASP Top 10 list. And it will usually cover like 95% of the potential problems you might have to deal with. And if you are really concerned about security, or you work with customers that are really concerned about security, you'll want to consider getting certified to demonstrate your InfoSec bona fides. So Silverstripe works with a lot of government departments and big businesses. So it made a considerable investment to be certified with ISO 27001. So another common standard in that space is SOC 2. So I'm not going to go into all the differences between those two competing standards. But if you are interested to learn more, I'm sure you can find plenty of fine security consultants that will answer all your questions and charge you a lot of money for those answers. So thank you for listening to me rambling about security for the last 45 minutes or so. I hope you got some value out of it. There's a lot of effort that goes into implementing and following security development processes. It's not flashy work, it's not glorious work, but it's very important, and it's one of those things that people only notice when things go wrong. In conclusion, I would like to give a big shout out to my former colleagues, Steve and Guy on the CMS squad, and the rest of the InfoSec team at Silverstripe. And also a big shout out to all the community members that take the time to report vulnerabilities in Silverstripe CMS. So their vigilance helps us keep Silverstripe CMS users safe on the internet. So.
All right. Any questions for Maxime? Yep. Questions. All right. Can we? Will he hear us? All right. So, gentleman in the back. Yep.
Well, first of all, congratulations on your new job. We're really sad to see you leave, but I guess it was nice having you. And thank you for the talk. I'm curious, do you know about the security TXT file, like this well-known /security TXT, to let researchers know how to contact you, and what do you think about it?
I don't have like deep knowledge about it. I don't necessarily have strong opinions on that front.
All right, thank you. Anyone else? Any other questions? Sorry. All right, that's it. Thank you, Maxime.
Cool. Thank you.